So 683. Kick-ass. Cool.
So we probably won't be given any problems when we're forced to write.
There is a couple in the homework, but they point out the problem. They actually ask you, write this now, don't they look similar? Oh shit. Okay. But in the actual work itself, that would be evil if they did that to you. So I don't think they do. I think it's only that one place. So I sort of hinted at the fact that if I start in our system and ask you to translate it to Babylonian, it's going to be more difficult. So think about this. If it takes multiplication and addition to translate from Babylonian to us, what operations does it take to go the other way?
Subtraction.
Holy shit. So if I wanted to write the number, what you got, Jeff? 147. I want to translate that to baby.
Divided by 60.
How many places do I need? I need
2.
the ones place and the 60s place. I don't need the 3600s place, so I can stop right there. Now, who has an idea how to start to do this?
Find out how many times go to 60 for the highest value.
I like it. Start at the highest value. So how many 60s go into 147? How many 60s can I use? 2. How much of this number? So 260. So right now I'm going to use my symbols while I'm working this out. The last step is going to be translated into Babylonian symbols. So I'm not trying to do everything at freaking once, right? So I'm going to write our symbols while I'm working it out. 260s takes care of how much?
120.
So how much do I have left to take care of?
27.
So then here I'm going to put, now you have a choice. What do you want to put?
The 3 things and the minus 1.
So you can put 3 things. Well, let me see. Let me put 27 here. So 2 would be 1, 2. And then 27 could be 3. So 30 minus 3. Or you could do 1, 2, and then 20. 1, 2, 3, 4, 5, 6, 7. Right?
So the whole T is the minus sign.
Yeah, this whole symbol means minus.
Okay.
I like it. 30 minus 3 is 27. Cool. Or you just write directly 27. Right? If you're the one with the freaking thing in the clay tablet, it's up to you. You decide. Okay, maybe. All right, so here. So try this one. So in Hindu Arabic, it's 4,985. So just to make sure you start off right, how many places are you going to need?
3.
1s, 60s, and 3600, exactly. So do it. So like I said earlier, you're going to divide and subtract. It makes sense because it's the opposite thing we're doing. 3600 goes into 4985 once. 4985 minus 3600 is?
1385.
Sweet. So that's how much the next guy's got to take care of. So I let my big dude attack it first. He takes a big chunk of it away. Then my next dude says, all right, let me see what I can take care of. 60 goes into 1385 how many times? 23. 23 times 60 is?
1380.
Good. And then 5. So my littlest dude is like, oh good, there's just a little bit left. So you can actually take care of it. So I need,
10 minus 5.
look at you.
So that would be
So now now take a minute and you try to write that in Babylonian symbols.
So how much space would you say is enough space to denote a space in between the place?
Busted, son. That was ill, right?
We don't want that kind of battle because I will lose horribly.
Just like use your best judgment.
Well, I'd say to your face that the space you come up with might be commonplace, so that's fine. No, that's, see, I was told you. So I'd say, like, right now, how much space did you use between the first and second? How would you write 23?
The sideways V, 3 things.
So this much space, so then I'd say twice that much space. And then the 5.
I'll get it.
What's up?
I don't know, I'm just getting confused with how we're getting the numbers on, like, the actual numbers itself. So we're just subtracting.
3,600 went into 4985 how many times? Once.
So we're just
So if 1 3,600 takes care of that much, how much is left? 1385.
Okay.
Cool. Do you guys get the idea with that?
I feel like if they use tens and ones like that, they could just not use the space. I mean, kind of like that whole Roman thing, the I before the X means something else. Like, couldn't you just know that 1 before 10 means the next place?
Yeah, but too bad you weren't around. So.
Oh, I would have done 10 minus
No,
5.
no, let me say this. Now that we've talked about a lot, we got one more civilization to talk about. We're going to talk about the Mayans today. But we will, I don't know if you noticed on the syllabus, it says something about a project on the syllabus. Oh, yes. Oh, you're all like, dude. So your project is actually going to be to create your own number system, which entire civilizations failed at. So I'm going to make you do it. And I've had some kick-ass cool shit. I'm going to bring in some examples from past classes I've taught, like last semester and then semesters before that. One year I had a couple people turn in something that was an improvement on our own frickin' number system. I was like, okay, you get some extra credit. So this project, you could do the bare minimum, which is take the numbers 1 through 9 and make stupid little symbols and then turn that in, and you technically will get credit because that's what the project is. You can get extra credit if you actually put more thought into your symbols. So one time I had the student do these inverted triangles, and every level of the triangle was the next place in the number. And I was like, dude, that's some kick-ass cool shit. I had somebody do like dominoes, and the numbers, and if you put them together, it meant multiply, and if you put them a different way, it meant add.
Oh gosh.
You kind of with me? So I'm like setting the bar high. So if you don't want to put a lot of work into this project, it's only worth 5% of your grade. You just have to do the bare minimum. You got to make some symbols. You got to have some kind of a little backstory about what your civilization, why they came up with these symbols, and you got to show me some examples. And don't worry, I'm not going to just leave you dangling on your own. You don't have to start. Please don't start on it yet. You can start thinking maybe. But I've got a little handout I'm going to give out. We're going to have a few classes devoted to working together, looking at what you got so far, giving notes to each other. So it's not going to be entirely on your own. You guys kind of with me? A little bit? All right, I just want to throw that out there because you said something that made me think I should say that now. Yeah?
So is that off the top of the project? Is that the whole answer? That little...
This right here?
Yeah.
Yeah.
Okay.
Because if I did 5 plus 23 times 60 plus 3,600, it would reproduce this, right?
Yeah.
So subtracting and dividing is the opposite of what I just did. So that's why one way is that, the other way is the other way. The other way is multiply and add. Yeah, I like it.
What's the improvement?
Oh, God, I can't remember now. This is from like 5 years ago. But I remember writing our paper, you have improved on our system. I'll have to look it up.
And you just
You didn't steal the idea?
It was that.
Well, it's like, you know, how likely is it that America will do the metric system? Tell me.
Not gonna happen.
And her improvement was not like, you know, crazy amazing that, you know, but it was an improvement. I think it used colors though, so that would also be a bit of a thing to get over. You kind of with me? So we can't even get America to do the metric system. And now you want to try to get the whole world to do a different number system? I don't think so.
You can use colors.
Totally, dude. And this is why I want to give you guys a few examples, because last semester, I don't think I gave enough examples, and my students weren't even sure how much flexibility they had. You have a lot, but your number system has to make sense. Like the dude that did the inverted triangle. So instead of symbols for the places, or instead of the 4 being in the middle, so it means 10, each level of the triangle was like 1's place and the 10's place and the 100's place. And it was cool. I was like, okay, that's really kind of nifty, right? And then like a filled-in triangle meant you got a full whatever it was, and then you make another triangle next to it for bigger numbers. It was like, holy shit. Anyway, sorry. And one other one I want to tell you about. This guy, he said his 10 and 100 and 1,000, those were vowels, and all the numbers were consonants. So when you put things together, it became a word, you know? So it'd be like 5,300, you know? So Neba, you know? I was like, damn! You see? So hopefully, I don't want to give too many examples, because some of you are like, I was thinking that. You, why did you say that? All right. Let me see. Let's talk about Mayans. Now the Mayans, I think this will be the last thing we do today. If you ventured into I don't know why I'm saying this first, but if you ventured into a Chipotle, hopefully you didn't buy food, because then you might be not here at the moment. I speak bad about Chipotle, but I used to go there all the time. If you've seen on the wall, if you look on page 182, the Mayans had these formal images of their gods that represented numerals. So some of the pictures that the Chipotle decided to, some of the images, especially the one in Mission Valley, I think, you know, next to the Target or whatever's over there, on their wall they have these Mayan god pictures, and I think a couple of them are kind of close to the symbols for numbers, this formal symbols for numbers. The informal symbols for numbers they used, they did have a 0, thank God. It looked like that. Right? It looked like a potato with butter on it. The Mayans, in fact, their whole system reminds me of food. So this is the symbol for 0. This is the symbol for 1. So what do you think the symbol for 2 is? That's crazy. Now, thankfully, at 5, they make it a bar, right? And what I call a pancake. So these are blueberries and these are pancakes. I just put that out there now because I'm going to say it at some point, right? So what do you think how do you think they wrote the number 8?
Bar.
3 dots over a bar.
Kick ass. A pancake with 3 blueberries on it. All right. There's no Mayans here today. They all left the earth at some point. So how do you think they wrote the number 10?
2 bar.
2 stack. I like it. So 10, double stack of pancakes. How do you think they wrote the number 17?
A stack of 7.
2 blueberries.
Oh.
There you go. 5, 10, 15, 16, 17. Do you guys see? So that's simple so far. I started with their symbols because their places are kind of weird. So the Babylonians use base 60. The Mayans use roughly base 20.
Roughly?
There, that's the word you have to be careful about. So let's see what they use. So here's their symbols, and it went up to 19, because their base is 20, basically. All right, so why wasn't their base exactly 20? I'll show you. If you look on the internet, you'll find all kinds of incorrect information about all kinds of shit, and you'll find incorrect information about the Mayans. They didn't have a purely base 20. What they had was they had a 1's place, and this is vertically. Remember, I told you that the other day. The Mayans and the Chinese, they both have vertical. They had a 1's place, a 20's place. Okay, everything looks great so far. If I could write the number 2, there you go, John. The next place, though, was not 400. The next place was actually 20 times 18. What is 18 times 20? What is 18 times 20? Let's try it again. What's 18 times 2? 36. So what's 18 times 20? And what's 360 roughly?
A year.
A year. There you go. You understand? Of course, we survived 2012, but they were obviously big on the year. They wanted their number system to have the number of days in a year, roughly, right? Of course, we got it all down. You know, we just had a leap day. We had an extra, did you guys notice that, February 29th? Or did you just stay in bed? Extra day? Sleep. Do you know that we have leap seconds? Not too long ago, like it's every, like this last one, the one before it was like 10 years before that, I can't remember, but they have leap seconds so that they can have everything that precise. Why are leap year? Why do we have leap years? Because our year is not exactly as long as the actual physical year the Earth takes to get around the sun is not equal to the year that we use. So that's why every 4 years we have a leap day. That's why you call it a leap year. You guys kind of with me? Did you guys know that's why, or did you just go, they want to make February bigger every now and then? I don't know.
Blame Rome.
Huh?
I just blame Rome.
There you go. All kinds of weirdness came out of Rome with the calendar, so don't you? And then to make it even more precise, we have leap seconds every few decades or whatever. Having to do with the fact that the Earth is actually, the moon is pulling us, is slowing us down. Our revolution rate is slowing down. So that's why leap seconds exist. Google it.
Does that mean like one time a year that there will be 61 seconds in a minute?
Yes.
So
Well, you know, yeah. So
do all the time clocks just change like your phone say?
well, if you have an atomic clock, it was built into it. So if you sat there and just stared at your clock, 11:59 in 59 seconds, and then it would have been stuck on that for 1 extra second or something. I don't know. Thankfully, I didn't do that. I don't know. I didn't celebrate that big. Everybody, quiet! It's gonna happen. Okay, all right.
Brought the extra second.
Now, thankfully, so you guys all understand, we can't go back in time and change it. Not yet. I don't know. None of you invented a time machine. So this is what they just wanted to do. The next place, they picked up by 20 again. So the next place would be 18 times 20 squared. What's that?
12.
I like it. Good try. Yes, there you go. There's somebody. Calculator. I like it. And so forth. All right? 2012, not just a movie with John Cusack.
To be fair, do they have leap days?
What's that?
Do they have leap days and leap years in the modern time?
I wouldn't know. When they say, oh yeah, a year's about 360 days, I think they didn't get that precise about it.
Yeah, so wasn't like 2012 actually like a decade or so before anyway?
Let's not get into that. It's like the people that say the Earth's going to end and then it doesn't, and they're like, oh, I miscalculated. Damn. Sorry, everybody. Sorry. Really? All right. You quit your job? I'm sorry. So, real quick, before we get out of here. You guys ready? All right. So let's start off easy. So it's always easier to start in somebody else's system and bring it back to ours. It's always easier because that's multiplying and adding. It's easy. So if I had this number. I like it. So how many places are there? It was a little easier. They had a symbol for 0, but it's actually, because of their symbols, it's a little easier to tell sometimes where things start and end. But if I didn't have this place, I have a 0 to put there, thank God. I don't have to leave some space. I actually have a symbol for 0. So there's 3 places, right? What place is this in? Let's start here. That's in the 1's place, that's in the 20s, and that's in the 360s. So how many 1s do I have? 7. And how many 20s? 11. Kick ass. And then how many 360s? 1. So then you multiply and you add.
So it's kind of like the Babylonians thing, where you multiply.
Babylonians and Mayans had the exact same concept as to how to put numbers together. They just had different symbols in different places. And of course, that's funny when you stop it. But do you understand? They had the exact same concept. They just didn't agree on the symbols they wanted to use and what each place would mean. But they had places, like we have places, right? So they didn't have to have a symbol that meant 10, 100, 1,000 like the Chinese did. They just knew if it was in the right place, that's what it meant. I like it. So what do you get for this? Just a 587, you said?
Yeah.
Okay. Just to get there. Okay. Cool. So let's try one going backwards. Let's try one starting in our system. So how would you put this into Babylonian 915?
Divided by 360.
Yeah, exactly. You first identify how many places you're going to need. So I need ones, 20s, 360s. The next one would be 7200. Become a 2. So I don't need that. So it's just like we did with Babylonians. You start with the big, you send your big dudes in first, and they take care of a big chunk of it, and then the little dudes come in and clean up the rest. So 360 goes into 915 how many times? Twice. So 915 minus 720 is
195.
195. 20 goes into 195
9.
9 times. 9 times 20 is 180. So I always, when I'm doing the work, I write all the stuff in my own symbol so I know what the hell I'm talking about. And the last thing I do is translate it back into their symbols. So 15 would be what? 3 pancakes. No blueberries, right? You got a blueberry allergy. 9 would be
Bar with 4 blueberries.
good. 1 pancake, 4 blueberries. I like it.
Chocolate chips.
Chocolate chips, whatever you like. And then up here,
Put chicken nuggets on those pancakes.
Chicken and waffles.
that's a little tiny speck of a nugget, man. I tell you. Here are your chicken pellets.
Popcorn chicken.
Yeah, fine. Is that cool? I mean, you guys get that? So once you get the idea of divide and subtract, start with the highest. The next section is going to be, you got to let the next section be nice because we're going to go back to using our own symbols. We're just going to talk about, well, what would base 7 look like? What would base 3 look like? What would base 16 look like? Stuff like that. Okay. Do I want to talk about that a little bit? No. I'm going to let you guys out of here. So that was section 4.2. We're done with 4.2. We'll get into 4.3 tomorrow. And tomorrow, not tomorrow, but relative to the class. I'll bring the little project sheet with me next time so you'll know what I expect from you and when.